So hi everyone, I am Kayum and in this video we will going to learn about uh, doubly linked list data structure in Python. So what is doubly linked list? It is a linear data structure available in Python, and you can add nodes and remove nodes and update the nodes using this. So doubly linked list we can represent it in the way as W traversal. Okay, you can traverse forward as well as backward. Okay, so this is how this is the way you can represent the doubly linked list. Okay, so there are two pointers here, main pointers. First one is head pointer, which will represent the head element, and tail pointer, which will represent the last element. Then next pointer, which will traverse to the next in forward, and previous pointer, which will traverse in the backward direction. So now we will going to see that how to create a doubly linked list in Python. So first of all, we will create a class name as node, and here constructor function we will give is okay. Now we will mention here the pointers, data pointer, which will hold the data, okay, which will hold the data of the memory structure, okay. And then self dot next previous, right, this will hold the previous element. Self dot next is this will hold the next element. Now we will create another class which will doubly linked list, okay. Dev again constructor method self dot head is equal to, we will say it as none initially, and the tail also none, right. So this is done. Now we will check if the doubly linked list class is empty or not. So if this is empty now, it will check it and tell us that self dot head is none, okay. That means the first element of the linked list is none, there is no element. This will represent if we apply this method. Then we will say insert value, right. I will tell you that insert, okay, insert and then position and value, right. Here we will create a new node using this node class, okay. And here we will check if the class is empty or not. So if the class is empty na, we will say self dot head is equal to self dot tail is equal to new node, okay. And if the class having some initial nodes, okay, so it will simply, what we will do, we will traverse, we will swap the elements, okay. Previous is equal to new node, and finally we will update the head pointers also is equal to new node. Okay, again similarly what we will do, if self is empty, then again self dot head is equal to self dot tail is equal to new node. And if this is not the case, if the self dot head elements, if the class is not empty, we will say previous is equal to self dot tail, right. And then self dot tail dot next is equal to new node, and then self dot tail is equal to new node. This is what we are just swapping the elements, okay. This will be the backup, and the next pointer will head to the new node, and finally we will update the self dot tail pointer, okay, this way. Now what we will do, we will check if the position is start, okay. If the position is start now, we want this block of code should be what we call as, okay, execute. And if the position is equal to end, then what we will do, we will say that represent this, okay. So this is all. So this is all about the insert, okay, insertion function, right. Now we will say display. Again we will use position current uh, forward, okay. For forward we will use self dot head pointer current backward, okay. Okay, and backward, if we want the backward, then here 10, right. Now we will loop forward and print it. Okay, data. After doing that, update the forward pointer. Okay, increment it using next. Okay, and now your while current, now this is for backward print. This will print the element in the backward direction. Okay, and then end. Here also backward is equal to, this will be the increment. Okay, previous. Keep sure that the next is for forward and the previous pointer for the backward. Now what we will do, again we will say if position is equal to forward, then execute below code. Okay, and this is if the position, if position is equal to backward, then execute below code. Okay, take care about the what we call as indentation. Okay, this will be the indentation. We will do it for this also. Okay, so this is all about the display. Okay, now we can test it. Okay, L is equal to, here we will say DL. Okay, now for I in range of 1 to 5, we will say L dot insert and position start, then I. Okay, and for J in a range of 6 to 10, L insert, then end. Okay, J. So this will insert the element into the inside the class. Okay, now we want to display it now, so we will display it using this forward, right? And you can see here, right, in the forward direction, this is the way we can get the element. Okay, now we will say for the backward direction, we will say backward. Okay, just 1 minute, I miss one thing, print. We want the on the new line, so that's why. Now we can see it, right? You can see it. Okay, this is a forward way of representing the linked list, and this is the backward way of representing the linked list, right? So this is how we can create a doubly linked list inside a Python. Okay, using Python. You can see pointers are important, and the while loops and the new node. This is how we can do it, right? Uh, Now we will let's see. Okay, for updating the value, new value. So current backward forward name. Current is equal to self dot head. Then while current, if current dot data is equal to value, then what we will need, what we say, current dot data is equal to new value, right? And here we will say current is equal to current dot next, right? Updated. Okay, and here we will trigger the method forward and self dot display backward, right? Okay, now let's try to update the element. Okay, for example, we want to update 4. Okay, is instead of 4 we want mm, 16. Okay, so this is a old value, current value, and this is the new value. Okay, updated. Okay, so guys, you can see we have successfully updated the elements. Okay, so this is the way. Again, update. For example, let's see 636. Okay, so you can see it, right? In the place of 6, it got updated to 36. This is how it will work.